So last time we looked at what that optimal combination of granola and Pop-Tarts were for the consumer. Now what we want to do is consider what happens when something changes. For example, income increases or prices change or even the consumer's preferences change. So let's take a look in the model what happens as those different components are adjusted. Well, what we saw in the optimal combination was that consumers would want 4 ounces of granola and 3 Pop-Tarts, and that gave them a total utility of $7.70. We saw that graphically by considering the budget constraint and the indifference curve. So remember, this indifference curve holds total utility constant, and the endpoints of the budget constraint were based on prices and income. So what would happen if, say, income increased? So say income changed to $12. Well, clearly, if we were spending $10 before in getting 4 ounces of granola and 3 Pop-Tarts, we're going to be able to afford more of the products to do that. And we can use that same general idea of marginal utility per dollar spent to consider what happens. But what I want to do is look at it graphically as well. So what changes in this model when someone's income rises? Remember, every point on this budget constraint represents what? Represents the consumer spending exactly $10. Well, we know if a consumer has $12, they can get what? 12 ounces of granola. If they have $12, they can now afford a 6th Pop-Tart. So what we see is that the budget constraint shifts out. And that leaves us with the opportunity for another indifference curve that gives us a higher level of total utility. And in fact, as we look at this, there's really 2 different combinations that we could see. So the first combination that we could do is take those extra $2 and spend it on granola. So we could have 6 ounces of granola and 3 Pop-Tarts. Well, what would we get for that combination? We'd get a total utility of $860. The other way we could spend those extra $2 is to get 4 ounces of granola and 4 Pop-Tarts. Well, what would that do? Remember, that last Pop-Tart allows us to now get 6 860 units of utility. So you see that these two are exactly the same. However, there's another thing that we need to consider. Remember, we talked about that idea of different combinations of these goods, but we also talked about fractional units. This implies spending both dollars on granola or both dollars on Pop-Tarts, giving us the same level of utility. Well, what does that tell us? That these points are on the same indifference curve, and they're also both spending $12. That means that it actually looks something like this. They're on the same indifference curve and on the budget constraint. That means there's this area in between, just like before, where a consumer could actually make himself or herself better off. So what happens if we allow this consumer to, say, spend fractional units? So what if instead of spending both dollars on granola or both dollars on Pop-Tarts, they split that, and in fact, now they could do 5 granola and 3.5 Pop-Tarts. What we'd see with that combination is they can actually get 865 units of utility, and that's better. That's this point now on this curve. And that actually shows us that the person's better off. So what we see is as we increase income, the consumer can decide how to spend that. And in the first case, they're actually equally well off. They're indifferent between those two. They're on the same indifference curve. But if we allow the opportunity to spend fractional units by half of a Pop-Tart, the consumer can make himself or herself better off as a result of that. What I want to do next is consider what happens when the price changes. So when the price changes, we notice something a little bit different. When the income increased, what we saw is that the budget constraint actually shifted out. Now, what happens if, say, granola stays at $1, but Pop-Tarts change their price? So remember, this 5 was really related to income divided by the price of a Pop-Tart. Well, if Pop-Tarts get more expensive, what happens? This point moves in. So say down here, we started with the price of a Pop-Tart being $2, and that meant it was 5. Well, now what happens if, say, that doubles? The price of a Pop-Tart is 4. Now this point becomes 2.5, and the budget constraint rotates in. You'll notice that original optimal bundle that we had, we can't afford that anymore. And so we'd see a lower indifference curve that we can obtain. We could also see what happens if, say, Kellogg's ran a promotion and they had a sale. And now, say you buy 5, you get another one, and so we have 6. Now that budget constraint can actually rotate out, and we can get to a higher indifference curve. Remember, we're always looking for that indifference curve that's just tangent to the budget constraint, because that tells us the highest level of utility that we can attain, given the money that we have available to us. So this is what the model would look like as we change sort of prices. The last change that we want to consider is, well, what if a consumer's preferences change? Remember, here we're just changing the budget constraint. That doesn't say what I like, it just says what can I afford. So from there, if we change preferences, what is it that needs to change? Well, where do we see preferences? We see that in the indifference curve. So the shape of this indifference curve would actually change. And what that would look like is a little bit harder to draw, although we know that if, say, someone preferred Pop-Tarts, we talked about it last time, what happens to this indifference curve? It actually gets a little bit steeper. Well, what would you expect to happen if someone now prefers Pop-Tarts to granola? Well, they're going to buy more Pop-Tarts, right? And so a steeper indifference curve would probably look something like that. And you'll notice that point of tangency moves sort of closer to Pop-Tarts and less granola. This one's a little bit more difficult because we'd have to actually know exactly how the consumer's preferences are changing and think about the shape of that indifference curve. But it does give us some insight in terms of how the optimal bundle will change with consumers' preferences. Well, where might we see the consumer's preferences change? That could be an example where, say, people are more concerned about the environment, so now people will buy more electric vehicles or more hybrids than they were before. It doesn't mean that the prices have changed. It just means given the current prices, they're more willing to benefit from that. And so what we'll do next time is we'll look at kind of combining all of this into one model of consumer demand.